So he had like this awesome comment. He said, "Isn't statistics a high school class?" And so I'm of course like, "This is a high school class." He's like, "No, no, no, no. I mean, there's like a whole separate class called statistics. I think it's even AP statistics, right? So it's a college class." So as statistics, it's amazing, statistics. We use it all the time in our world. We wouldn't have modern medicine without statistics. We wouldn't have a lot of things without statistics. So learning about statistics is extremely important. So we're kind of doing like an ABCs of statistics here in Algebra 1. And then you do a little bit more in Algebra 2. So you get a nice background. So if you do want to take AP statistics or statistics when you get to college, you have the background for it. So that's kind of why we're doing this here. What's nice about statistics is, we spend a lot of time doing algebra-based math, Algebra 1, Algebra 2, we're getting you ready for calculus, all those good things. But statistics sometimes can be more useful in real life than some of the other algebra-based math. And listen, I love my algebra-based math. But if you decide someday, I'm not going to be a mathematician, you're going to need statistics in almost any field that you pick. Going to sales, a lot of statistics. Sports, a lot of statistics. There's a lot of statistics in real-world application. Question?
Was calculus hard to you?
I will answer that another time. The short answer, not really, but I also had the best teacher on the planet. But I don't want to talk about that now. I want to talk about statistics. All right, so you just did a whole big worksheet on that. Let's see if you can this should take, 5 minutes? See if you can find the average. Anyone have the first one yet? Oh, yeah? What did we get, 80? 81.75. Did anybody get an average for the second one yet? You have that one, Ryan? What'd you get? $447,000. Oh my goodness. What about number 3? Did you get it? What is it? You're getting it. What is it? Did anybody get that one? This one's hard, isn't it? But now, did you look at all these different tens? Yeah. Well, let's come back to that. So, tell me how you got this average of 81.75.
I added up all the percentages, and I divided by 4.
Divided by 4, you did that. Same thing with this. We added up all these numbers. We divided also by 4. And then, wow, this one's confusing. Now, when we say average, did you get a number for that one?
Yeah.
What did you get?
9.91.
Is that right? Anybody else get that number?
No.
9.39. All right, let's think about, though, what we mean by average. So you say average is add the numbers, and let's divide by the numbers we have. Now, I'm going to call that n. And this is a statistical thing. The number of numbers that you have is called n. So 1, 2, 3, 4, this n is 4. 1, 2, 3, 4, this n is 4. What's the n here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. But n is kind of universal in statistics. It means how many pieces of data you have. So that's average. Now, there are other averages, aren't there? Yeah. What are other averages? Median? Well, this is mean right here, isn't it?
Yeah.
Median is an average also. It's just a different way of looking at average, right? So what's the median of this one? Well, she told me, well, you put it in order. And then you find the middle numbers, but oh no, now I have to average those. So what's 87? Do this for me. 87 plus 92, divide by 2. 89.5. And then what's the median here? Not even in order, so now I gotta put it in order. Boy, what a thing this is.
Well, not really.
No, it's okay. So again, I've got an even number here, and what do I get? 2 of these. So somebody has to average these 2 numbers, and you get
569,000.
And then, oh, what a mess. What's the median here? Well, let's see. There's 23 numbers. It looks like they're in order. So let's see. That means I'm going to have 11 on each side, and there should be my middle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? And then there's 11 behind her, so this was a median of 10. Well, that was easier, right? That was certainly a lot easier than trying to find the median.
Because it was already in order.
But now the question is, well, so why don't I just get the median here and not bother with the average? Or maybe, do I want mode? What's the mode of this one?
No mode.
There's no mode, right?
No mode.
What's the mode of this one?
No mode.
No mode. This one has a mode, right?
12.
12. When do you decide I want a mean, I want a median, I want a mode? How do you know which one? Now, I know you know how to find it. You guys are brilliant at that. How do you know when to use one? And that, I want to start with talking about that. So let's just review what they are. Our measures of central tendency, that's what we're calling these values here. It's one number that's used to describe a set of data. I could have hundreds of numbers, but I define it with one number. And that's that measure of a middle number somewhere. Let's see if we can find a middle number. That's a measure of central tendency. So mean, median, and mode, I know you know what that is. Here's a new name for mean. You may or may not have seen this before. So it's an X, and it has a little bar on top. You know what we call it?
X bar.
X bar. That's exactly what we call it. X bar. So if you hear me talking about X bar, I'm talking about the mean, the one where you add all the numbers and divide by the number that we have. It's a calculated middle. The median is the actual middle, and the mode is the number that appears most often. Now you guys have worked with range as well, right?
Yeah.
Now you told me the range is the biggest number minus the smallest number. Range is not a measure of central tendency. It doesn't tell you anything about the middle number. This is about spread. How far apart are your data values? And we're going to be spending a lot of time talking about other measures of how far apart the data is or how close together the data is. So range is one way to look at that. And so we're going to kind of discuss a little bit what all these measurements mean. So let's look at advantages and disadvantages of these different things here. So what's good about a mean and maybe what's not so good about a mean? What's good about it? What's good about it? Yeah. Yeah, so what's good about that? Yeah? It's exact. I like that, yes. It's very calculated, it's exact, and it's relatively easy to find. You told me how to find it pretty simply, right? Okay, I like that. It's easy to find. I've got some things here, but okay, so it's exact. I don't like that word. I'm going to say it's kind of easy, and easy is relative, right? What does that mean? But we know the formula to find it. What was the other thing that was said? There was something really good there I heard also. Anything else we want to say about it? What's bad about it? Yeah? Easy to make mistakes. Sure, it's easy to find unless you have a lot of numbers or they're complicated. So error prone maybe, sometimes. Yeah?
If you have a big gap between numbers,
Yes. So if your grades are 99, 100, 97, 94, 40. Yeah, what happens, right? So I'm gonna call those oddballs. Oddballs can make the number change drastically, right? So that's not so good. Now let's talk a little bit about medians. Now median is an exact middle. What's good about that? Now as we saw in the previous slide, this one also is kind of easy to find. It does depend on your data. But when we looked at that last thing with dress sizes, certainly was a lot easier finding the median, wasn't it? You don't have to worry about, oh, I got all these numbers and I typed one in wrong like you would up here with mean. It's basically finding it. Now, manually finding is a little hard, right? You got a big list of numbers, so the manual processes can be difficult. What might be good about this, and I'm thinking what Noah said before. So let's say we have my grades, 90, 100, 97, 98, 40. What would my median grade be in that situation? It would be somewhere in the 90s, right? And is that a better judge of how I am as a math student if those are my math grades? Yeah. Everything is really high, one kind of clunker. Does that mean I'm a terrible math student?
No.
That means there's one topic maybe I don't get, but am I a horrible math student? Probably not. Probably means, well, you're a 90, everything else, you work on this, you're probably going to get it. So it kind of ignores the oddballs, or it's not affected by the oddballs as much. Right, so the data that's very different from other pieces of data. Now the mode, that was a little bit more complicated in terms of advantages, disadvantages. First of all, easy to find? No?
Yeah.
Yeah.
Depends, right? It depends on your data.
Depends on the numbers.
But if it's in order,
Depends on how long.
not so bad. So not too hard to find. What does it tell us? Is it useful? So, I mean, that's a question. When would I use a mode as opposed to one of these others? You think you know? Well, what do you give me? I'll take whatever you got for me. Oh, so the eyeball makes it weird. That's an interesting point. So let me go back here. These are dress sizes, right? So this is what the person has. And then let's say, we have a couple of large sizes. Yes, some people are bigger than others. So maybe there's like, size 24 in here. Is that going to change my mode in this situation?
No.
Probably not. It's going to move me over one, right? But I still have all these 10. So mode also not really affected by the oddballs necessarily. But what is the problem with mode? Now, when we looked at the first two examples that we did, what was the mode? There wasn't any. So sometimes there's no mode. And then we have the other problem. Sometimes more than one mode. Right? Can I have more than one mode?
Yes.
And then the question is, what am I going to do with this thing? What do I use it for? I like the dress shop example because that is one of the few cases where mode is useful. If I am a dress shop and I want to make sure I have the right number of sizes, and let's say this was more an inventory of the sizes I sold. And if it turns out I sell more size 12s than anything, that mode, what does that tell me about when I have to order new dresses in? What size should I get a lot of? Right. So mode can be very useful as your measure of central tendency in a case like this. But otherwise, not so much. Not so much. So the eyeball is a problem, though, for other things. Now, I want to look at this example here, and this was on your paper. You guys looking?
Yeah.
So I've got these numbers here, and these represent housing prices. Now, I want you to take a moment, see if you can find the mean, the median, and the mode. And then I want you to think about what's the best one that describes this data. Yeah, so we're finding that this manual method you're using is pretty hard. But before we get to a little faster way to do it, let's see what we got here. Now, what's the best representation? Somebody wants to move to Ashburn. What's the, that's a question you have. What's the average house price? So what should you tell them? 564,286, 590, 615. What do you think? What do you think, Ryan? This one, how come?
It's the average of all the houses that you build.
It's a calculated average. It incorporates all the prices, so we want to do that. That's one reason. Yeah? It's the cheap because it's the cheapest. Now, I want the most accurate. So this is if you want to fool somebody to think it's going to be very cheap. Is it cheap to live in Ashburn?
No.
You may or may not know this, but no. Houses are expensive here, right? So you want an accurate picture. If you were moving somewhere, don't you want an accurate picture? Now let's say I add something else to this pricing. Let's say, you know how occasionally you see one of those old kind of shack-looking houses? It's been in Ashburn a really long time. I don't know how it's standing up. It looks like it's breathed on. It might fall down. And somebody's trying to sell that, and let's say that one's only $50,000, mostly because of the land it's on, right? What's going to happen to your mean?
It's going to go down.
It's going to go down. Is that making the accuracy better or worse for somebody trying to get an idea of the housing prices? Worse. Or maybe you don't have a shack. Maybe somebody, are we okay? Yeah? Maybe somebody custom built a home. And it's got marble stairways and 4 floors and, oh my God, it's like got diamonds sparkling on the thing. It's $2 million right in Ashburn because right? What's that going to do to your mean?
Make it really high.
Go artificially high. Is that what you're going to expect to pay? Most of us aren't buying $2 million. Maybe you are. But most of us are, and I know I'm not. So what might be a better measure for housing price? What do you think? Why?
Because
when you talk about looking at different places, one measure of the economy is what's the median house price. They look at median because they want to not worry about the oddballs. They say, in general, what is it costing to buy a house? They will look at median. They don't use it mean. So if you want to kind of not let those little oddball numbers get in your way, you really want the median. Now, mode, is that helpful necessarily? There could be no mode. You know, how often do houses cost exactly the same? And if you look at real estate listings, they hardly ever do. And it doesn't, they don't mean anything. So we're probably not using mode. So median works better if you don't want those little oddball representations to kind of sway the data. Yeah?
I'm a little bit confused about names. Do you add them all up and then divide?
Yes.
On your calculator?
Yes.
Or just add them up?
If you went and if you did this, let's say it was only the first few numbers. I'm only doing the first three. If you did this, is that correct? No. What do you need to do? That. But I'm telling you, don't even worry about it because I'm going to show you another way. I might as well show that to you now. Let's do that now. So, get your calculators up, turn it on. If it hasn't been cleared from the user before you, second plus 712. If it's your own calculator, you don't need to do this. Please stop talking while I'm talking. I want everybody to be able to hear this. So here's what we're going to do. You're no longer going to be just adding in the numbers, you know, so we're not going to make that mistake ever again. Now I will say this, some people fight me on this. I don't want to do this in too many steps and it's too hard for me. So get over that. The first time you do it, it might feel a little awkward. The second time, a little less so. After a while, it becomes automatic. So watch what you're going to do. So look for the stat button. Now, where is that thing? So you see your second button? You see the alpha button?
Yeah.
Move to the right. You see the stat button?
Yeah.
Press it. And we all there?
Yeah.
The first thing you got edit, calc, and tests. We're not using tests in this class. You know, that's for other things. But edit. We want to edit. And what happens here is you get a list. And this is where you put your data. So if I wanted to find all this data, I could type in 625,000. 1, 2, 3. Press enter. It's in my list. And look how I'm positioned at the next one. Now enter 585,000. Press enter. And do the same for all the numbers. I'm just adding the numbers on this list here.
Yeah, I can, where are you going to go? Added?
You already did it?
I can't. Press edit. So,
Not too many zeros, I can't see what I got here. Where's it going in? So I'm adding in all my numbers, 615, 1, 2, 3. Oh, 507. Now, do I really need all these 3 zeros at the end? I could have done them all. I didn't have to. I would understand that I need that.
Could you just, like, not put in the zeros, and then when you're done,
Add them back in.
times it like that?
Yes, absolutely. So just for the sake of argument, putting them all in there. Stop talking when I'm talking. All right, now, check. I can't even tell you how important this is. Check, do we put the numbers correctly? Garbage in equals garbage out, right? So did I do it right? 625, 585, 590, 350, 615, 570, 615. It is worth the, that took me what, a second? A second?
Delete it and do it alone.
You can just press the, see where it's highlighted, press the delete button, or you can start just typing it over. The delete button is, look right here where it says Del. Yeah. Or just start typing right over it, it should take it. Once your data is correct, watch what you do. Now, if your data's not in, that's okay, just look up and watch. Stop talking while I'm talking. Everybody's looking up. You are going to press the stat button again. Now this time I'm going to make a calculation. So you're going to use this little right arrow to light the calc part. Now remember, some of these look a little different depending on the model that you have, but so it should be similar. We're going to go with one variable statistics, number 1, and then press enter. Press enter again. Okay. I'll do it one more time. Everybody's looking up? Stat. Everybody's looking up because some people weren't before. Move over one to the right where it says calc. 1 bar statistics, press enter. Look at my X bar. X bar is another name for me. And look what it is. There it is. Other stuff. We'll talk about that. And n equals 7. What do you think that is? Remember n? What's n? Number of numbers. Did I put 7 numbers?
Yeah.
I sure did. Now, there's more. See how this little down arrow taking? I got more stuff for you. So you press this down arrow right where I'm pointing on the board. You see where I am?
Yeah.
Press that, press that, press that. Look at all this other stuff. Minimum x. What do you think that is? Smallest number in the batch. We'll talk about Q1 in a moment. MED, what's that? Median. Q3, we'll talk about that soon. Maximum x, your biggest number. No fuss, no muss.
Oh.
Are you ever going to find the median by, let's put all the stuff in order, and let's go from shortest, biggest, small, you know that little thing we showed you? Ever doing that again? No. This is a, stop talking while I am talking. This is a situation where you want to do this on the calculator. Our goal in our statistics units is not, how do you find this number? We're going to be using the numbers. So you want to find these numbers as fast as you can. We're less concerned with do you know how to cross out numbers to find the median. Here it is. We're going to be using medians for other things, okay? So this is all important stuff related to median. And you can scroll back up. And I think some of the newer calculators might be a little more fancy here, getting back and forth. But look at that, just like that. That's how I got my mean, and I got my median in 2 seconds. And I knew they were right. Median, you're just going to scroll down after you do your 1 bar stats. Oops. Press stat, press calc, 1 bar statistics, and then enter, and that's all your data. Okay? So we'll be doing more examples of that. We will. Now I do have the calculator. So look how crazy, complicated that looks. I did print that out for you, and I will give that to you. One thing we didn't talk about was mode and range. Since they don't tell us the mode or range in here, how can I find, first of all, the range? See how they gave us the minimum and the maximum? So you will just have to do that subtraction separately. All right, well, we'll talk in a second. Let me just do this. If you want to find a mode, the easiest way is to sort the data. So you press stat, you're back here. You see this sort A? If you move to that, it's sort in ascending order. Sort. So you press that button. It's waiting for you to tell you what list you want. Now, I put all my data in list 1. Hopefully you did too. If you look on your calculator, if you look above the 1 key, you see like a little L1 here? Look on your calculator above the 1 key. See an L1? It should be the same color as your 2nd key. So if you see that, it means press the 2nd key and then press 1. You're going to get that little markup there. And so sorting list 1, it just says done, but then you go back in your list and edit it. Now they're in sorted order, so if you're looking for a mode, it's easier to see when it's sorted, if you need a mode. We're not going to be using mode that much, but I just wanted you to know what it was. Okay? All righty, we're moving on. Yeah. So comparing data is really what this is all about. Our SOL is not about can you find the mean, but can you compare data. So this is kind of a typical question. It shows the difference in grades for 2 different students in a math class. So here assignment grades, here's Brian's grades. What's the difference of the means? Which student had the highest median, and which student had the lowest mode? So basically what you need to find for each one of them is, well, I need to find the mean, that's my X bar, and I need to find the median, and I need to find the mode. Well, how do I do that the new way? Oh. Right? Please don't start adding 90 plus 88 because it's too hard to remember the other way. Trust me, you do this a couple of times, it's easy. So let's start from scratch. Do a stat edit. If you want to erase the list, everybody watching? Right? I'm moving the up arrow. See how L1 is lit now? Yep. And then I'm pressing the clear button and enter. See how it's now empty out? And now if I want to put Simon's in, I can just type his grades in. I'm putting in Simon's grades because we have to find his mean and his median. You really, this is not the kind of classes coming up where you can tune out and then try to tune back in. It's not going to work. All right, now I'm in list 2. I'm putting Ryan. Why not? putting it in. Everybody's putting their data in. I hear a lot of shuffling and doing. You should be putting the data in. Now, after you type your numbers in, what should you be doing? Checking them. Check them. Stop talking over there. I don't know what goes on there. I checked my data. Some of you are still typing in. But let's look up. I'm going to do work on sign in first. He's in my list 1. Stat. Move over to calc. Press enter for 1 bar stats. Press enter again. What's his mean? I'm going to round this to the nearest 10th. 85.7. Hang on. Yes? All right, then you have a mistake in your data, but just let's finish this. I'm going to scroll down for my median, 86. These numbers are small enough I can see his mode is 84. If not, I would have put them in alphabetical order and just looked for it. Sorted order, sorry. All right, if you're having problems with the calculator, just look up. Because I want you to see how it's done properly. Just look up and you'll deal with your calculators. Now I want to do Ryan's grades. So I'm still going to hit the stat button. I'm still going to go to calculate. I'm still going to hit 1 bar stats, except Ryan is in list 2, right? So 1 bar stats, you're supposed to tell it what list you're working on. If you don't tell it a list, it does list 1. But I want list 2, so look at your 2 keys. See how that's now 2 there? Same color as your second button. Now I'm working on Ryan's data. So his average, his mean is 83.5. His median, scrolling, 85. Still scrolling now? And then I'm looking here. Can I see his mode? There's not enough numbers here. 85? Yes, question.
I've got everything to help, so I go to, I'm trying to find the name for the, Ryan.
Okay, he's in your list 2, right?
Yeah.
So you do stat, cal, 1 bar stats. Before you hit enter, you're going to press the second button and the number 2 to get list 2. Then you press enter, it's working on that list. And then you should be able to get that data. Now, if you did this by hand, you'd be sitting here forever. The goal is not, can you find this by hand? The goal is find it quickly and answer these questions. So what's the difference of the means rounded to the nearest whole number? 2. Right? Difference means subtract. Who's got the highest median? Simon. Who's got the lowest mode? Simon. So remember, I don't want you doing these by hand. I don't want you taking 5 years to do these questions. They should be relatively quick. Calculator, find good information, answer some questions. Make sense?
Yes.
Okay. I know some of you didn't get everything in. I will come back to some of your questions if you have trouble with the calculator. But let's just, a little bit more. What's a graphical display? Now, used to, everybody knew this coming in. I don't know if you still do. A graphical display that we can use to look at data, and there's my hint. This is a cat. This is my sweet little Professor Kingsfield, the late great Professor Kingsfield. He's sitting on a box, and he's got these things right here. Yes. So we're looking for, ever hear of a box and whisker plot?
Oh, yeah.
Remember that thing? How many people have heard about that before? Box and whiskers.
Well, we went over it last year, but we didn't go into it.
You didn't go into detail. Okay. Awesome. Well, here they are. I'm going into detail. It shows us median and quartile data, whatever that is. So here's what they kind of look like. Maybe if you see it, maybe you might remember it slightly better. Stop talking. There's 5 pieces of data that is represented on a box and whisker. Right here's your box. These little things are called whiskers. Lower extreme is just another name for the smallest number in your data. Upper extreme is just another name for the biggest piece of data that you have. The median, you know what that is, it's your middle number. Now these lower quartile and upper quartile, it's as if you looked at the median and the lowest number and you found its median. That's called the lower quartile. If this upper quartile, are you listening? Look here. So the median and the upper extreme, if you take the median of that data, you get an upper quartile. So you're basically splitting the data into fourths, and that's quartile. Quarter is a fourth, right? So here we go. The median is the midpoint. The lower quartile is the midpoint of the lower half. The upper quartile is the midpoint of the upper half. Lower extreme is your smallest piece of data. Upper extreme is your biggest. You know what a range is, right?
Yep.
A range is the biggest minus the smallest. Are we all listening?
Yes.
Because this is the question I get the most. What's an interquartile range? An interquartile range is the length of your box. It's the difference between the upper quartile and lower quartile. And each of these quartiles is 25% of your data. Now, the boxes don't look like it's 25%, do they? Because it's not 25% by value, it's by number of points. So if I would have had 20 points, 20 data points, it means that in this range of values, I've got 5 points here. I've got 5 points in this range of values, 5 points here, and 5 points here. These numbers represent how far apart they are. So I had some number 20, maybe I had 25, 20, 47, and 50. Those are my 4 numbers. These 4 numbers might be 50, 52, 60, and 69, right? They're closer together, so the box part is smaller. So this is just representing how far apart are the numbers, not how many numbers you have. That's kind of an important point there. So if you're constructing one of these, this is how you do it by hand. Really what you do is put it in the calculator. Yeah, well, no, I'm just telling you, you have to find these little pieces of data. You put it in the calculator, and then you run stat, calc, 1 bar stats. Because I'm running out of time here a little bit, I'm going to cheat a little bit. Pretend I did that. Because what's going to happen is I'm going to scroll down, and I'll tell you what I'm going to look at if I turn this on with the other data. If you scroll down, that's your lower extreme. That's your lower quartile. Q1 is the lower quartile. Median is median. Upper quartile is 91. Max is 94. So you put all your data in, run your 1 bar stats. Scroll all the way here. These are the 5 pieces of data you would need for a box and whisker. And I'll tell you what it is for this one only because we're running out of time here. The median is 35. The smallest value in there is 16. The biggest value in there is 67. The lower quartile, so if you split this in half and then take the median of that half, it came out to 23.5, and the upper quartile came out to 51.5. So if you are to build a box and whisker, what you do is you make a mark for these 5 values. Median at 35, I'm just going to make a line up here. Lower extreme at 60, you have to estimate a little bit. Maximum value at 67. Your lower quartile at 23.5, your upper quartile at 51.5, and now all my 5 marks are here. And if you get that far, you get 5 marks, there is a line for you to do that, right, on the back? Now your middle 3, that's your middle 50% of your data, you're going to make a box there. You kind of join the tops and the bottoms, so you have a box. Middle 50% of your data is in this range of values. And then your whiskers just kind of connected. Whoops, I don't want trouble with a straight line here. And it says these are kind of your outer values. Remember, 25% of your data is here. 25% of your data is here. 25%. 25%. Okay. So what percentage of the data, and I think I've got this on this chart here. Yeah. So here it is kind of a little bit neater. Here's our values. What percentage of the data is greater than 35? So here's 35, right? If this is each 25%, what percentage of the data is bigger than 35? 50%. What percentage of the data is bigger than 23.5? 75%. What percentage of the data is less than 51.5? 51.5, which is my upper quartile. Less than 51.5, I've got 3 boxes, right? 75%. So you're just kind of counting them. If it said what's less than this 23.5, that would be 25%. Does that make sense?
Yeah.
I want to make sure we got that. What value is 25% of the data less than? What? Here's 25% of the data less than your lower quartile, 23.5. If you're at 23.5, 25% of the data is smaller than 23.5. So I'm trying to ask, it's a little bit awkwardly worded there. Okay? And that's all there is to a box and whisker plot. That's all there is to it. You're plotting those 5 values, you're looking at the middle 50 with little whiskers to the outer 25%. I think that's kind of where I think we'll stop here. Questions?
Are we gonna review this?
What?
We're gonna review this.
Well, what's your question? Ask now. Because if it's like, this is crazy confusing, I don't want it to be. This is kind of the easy part of it. So please ask the question. I mean, yes, but I want you to be able to go and do your homework. Function whisker. So how do you find an what's the interquartile range? I'm going to use IQ for that. How do you find it?
The box from the left.
It's the length of the box. Upper quartile minus lower quartile. You would subtract these 2 things. How do you find the range? Subtract the digits. So those are just some of the numbers here that you're going to play with. It's not as complicated as you see. You want to move it. And that's a box of whiskers.